DALI Alliance webinar, brought to you in association with ARC magazine. My name is Matt Waring, I'm the editor of ARC, and I'll be taking you through proceedings today. Just a few bits of housekeeping before we get going. Today's session will last around an hour, with two presentations from Scott Wade and Paul Drosihn of the DALI Alliance, lasting around 40 to 45 minutes. This will then give us a good 15 to 20 minutes for a Q&A session afterwards, and you can ask your questions at any time using the Q&A box. If we run out of time and our panelists are unable to answer all the questions during the live session, they will provide written answers at a later date, so don't worry if we don't get to yours, but please send in all of your questions and we'll try to get through as many as we can. Presentation materials and a recording of the webinar will also be available afterwards as well. So, what is on the agenda for today? After a brief introduction to DALI, DALI-2 and the DALI Alliance, Scott will describe the key technical features of DALI, including control, configuration and querying of DALI devices, as well as grouping and scenes. He'll then talk about lighting-specific features of DALI, such as dimming, colour control, and emergency lighting. He'll then hand over to Paul, who will talk about DALI in smart buildings, focusing on the availability of data and its role in improving productivity and well-being of occupants. He'll then explain how DALI is creating solutions for wireless connectivity and working with various partners to create new standardisation programs. We'll then hear briefly about the DALI Lighting Awards program, which is supported by ourselves at ARC, before answering your questions. So, without further ado, let's get into it, and I'll hand you over to Scott, who'll get us started.
Thanks very much, Matt. Good morning, everyone, and good afternoon or evening. I'm Scott Wade, the Technical and Certification Manager for the DALI Alliance. So let's start by looking at an overview. What can DALI do? So DALI is for digital control of light quality with intelligent feedback, and it provides precise, repeatable light output control and a standardized dimming curve. We have occupancy and light sensing, so with using devices called input devices. DALI-2 sensors and other input devices provide information to the system. Luminaire energy and diagnostics data can be obtained, so that's data for enhanced asset management and performance monitoring. Also emergency lighting and the automated tests that are required in emergency lighting systems. We'll look at that a bit later. As well as color control for human-centric lighting, enhanced comfort and well-being. And we already have tunable-white color control as part of the DALI-2 certification. DALI is already positioned to participate in the Internet of Things, and we'll look at some of the data that's available to help there. And new specifications will create DALI connectivity for wireless networks and IP-based networks. We'll have a look at the current state a bit later on when Paul's talking. So first, an introduction, DALI, DALI-2 and DIA. So DALI stands for Digital Addressable Lighting Interface. And it's the industry standard protocol, that's just a language for bi-directional digital communication between lighting control devices. It is dedicated to lighting, and for lighting it has a very rich feature set. And DALI is technically managed in the open global standard IEC 62386. DALI-2 is the latest version of the protocol, and that's the name of our certification program. And that certification is driven by DIA, the Global DALI Alliance. And this ensures interoperability through testing and certification with trademark use. And you can see the DALI-2 trademark on the right there. So DALI, DALI-2 and the D4I trademarks are controlled by DIA for use by our members. So some key features of DALI-2. It's the latest version of the DALI protocol, and it focuses on multi-vendor interoperability backed by our DALI-2 certification. DALI-2 has more features and clearer specifications compared to the original DALI version 1. It extends to all devices in a lighting control system, including the input devices such as the sensors and application controllers, the devices that take control and make decisions. It's designed for backwards compatibility with older DALI systems. So if you still have the DALI version 1 control gear in a system, that's not a problem. It's designed to work with that. together in the same system. And it also includes more detailed and comprehensive testing requirements. As an example, to test a DALI-2 LED driver takes probably about 3 days worth of testing, whereas with DALI version 1, it was about 1 day. The DALI Alliance itself is an open global consortium of lighting companies that aims to grow the market for lighting control solutions based on DALI. And you can see a selection of our members on the right. It's also known as the Digital Illumination Interface Alliance. And we have almost 250 members worldwide, industry leaders in lighting and control. Membership allows certification or registration of products, 1,400 DALI-2 certified products in our database today, and over 1,350 DALI version 1 registered products. So you can see DALI version 2 has already overtaken the DALI version 1 products. And membership allows DALI, DALI-2 and D4I trademark use. So DALI-2 certification. So DIA drives the DALI-2 certification program, and we have ongoing work to add new features and new product types. And the certification involves rigorous and detailed testing. And as I mentioned earlier, about 3 days now to test a DALI-2 LED driver, to do full testing. Now, following the testing, there is verification of the test results. So the testing could be done by the members or by an accredited test house, but the results have to be sent to us for verification. So this results in high confidence of interoperability between products. And once the products have been certified, then trademark use is allowed. And the products are traceable in the DIA database. And that's the web link if you want to search for any products, and you can filter by product types on the web page there. So D4I, this is a more recent trademark that we've added to the portfolio, and D4I is an extension to DALI-2. Control gear require a minimum set of functionality for D4I. So if the control gear has D4I trademark, the trademark on it, then you know there's a minimum set of features that are included in that control gear. And control devices require functionality to aid the plug-and-play operation. So look for the D4I mark if you want those features. And D4I is targeted especially for intra-luminaire use, where DALI is inside the luminaire. And there's an example here of street lights, and in collaboration with Zaga, luminaires meeting the requirements for Zaga and D4I can be Zaga D4I certified. And you can see on the bottom right the Zaga and D4I logos together. And this ensures that it's easy to add or upgrade the sensors or the communication nodes to luminaires. And you can just about make out there's a small sensor there and a connector on the luminaire, the Zaga, in this case a Book 18 outdoor connector, allowing the sensor to be plugged into the luminaire. So that's one of the applications, and that's indoor applications are also coming up as well. Sorry, I missed one. So future-proof luminaires that can keep pace with rapid developments in digital networking and sensing technology. That's what this is enabling. So it's future-proof because you have the ability to very easily change the sensors or communication nodes that are plugged onto the luminaire, either on the top or underneath the luminaire. So some key technical features of DALI. So DALI enables control, configuration, and querying of the devices over a 2-wire bus. So DALI power and data are on the same pair of wires. So it's just 2 wires providing low voltage power, and that can be used to power some devices such as sensors. Now, DALI provides individual, group, and broadcast addressing to any DALI device. And you can recall pre-programmed scenes. So very efficiently, you can send one command, a scene recall command, that affects some or all of the control gear, all of the luminaires in the system. And this is flexible, so you can reconfigure using software. You don't need to change the wiring. Each DALI subnet has a maximum of 64 plus 64 addresses. And it's written in this way because you can have 64 control gear, such as LED drivers, and 64 control devices, such as the sensors. And it provides robust digital communication. DALI, the communication signaling rate is relatively slow deliberately to ensure it's robust, but due to the very efficient use of the commands and addressing schemes, typically you only need 1 or 2 commands to affect all of your lighting system. So it's fast, efficient, and robust. And it also includes the two-way exchange, data exchange and feedback. So that's the querying. You can ask questions of the control gear or any devices and get back the information from those. So commands and sequences. So we mentioned that it allows control configuration and querying. And these are the 3 basic types of commands. So control, and just some examples. You can start a fade to a defined light output level. There's different ways of starting fades. Recalling scenes, so that can affect one or a group or all of the lights together, and turning the lights off. These are just some examples of how you can control the lights. Configuration examples, changing the fade time or changing the light level stored in a scene. And there's obviously a lot more you can do besides these examples. And querying, asking what the current light output level is, or asking, is there a lamp failure in the system? So these are the 3 basic operations, and the commands can be addressed either to individual devices, we call them short addresses, or to a group of devices, or broadcast to all devices. And this makes the communication very efficient. And scenes also allow fast and efficient recall of light levels, and later you'll see it's not just level, but color as well. And that's across the system. Each item of control gear has 16 scenes built in, so they can be pre-configured, and a single go-to scene command instructs all the lights or any combination to go to the individually predefined levels or colors or both. So the wiring and bus power. So I mentioned earlier, DALI uses a 2-wire bus for communication and data. The power and data is on the same wires. So the picture there shows a 5-core cable, and that's typical of an installation where you've got the mains supply going to the luminaires, as well as the 2 wires for DALI, all bundled into the same cable. So it's very convenient and quick for wiring. The DALI bus must be powered to allow communication, and you can have up to 250 milliamps supplied to the DALI bus from the bus power supplies. Now that can be used to power bus-powered devices such as sensors and push-button controls. The cable itself is 2-core, and 1.5 square millimeters is recommended. And with that, it allows the maximum recommended distance of 300 meters between the furthest apart devices. And DALI is polarity free, and it's a free wiring topology. So you can connect the wires either way around, except for the bus power supplies, of course. If you have more than one of those, they need to be consistent. And also a free topology. So you can daisy chain, or you can use star connections, or even a combination of those. We don't recommend closing the loop. That can cause other problems. So wired DALI lighting control system example, and we'll build up this example stage by stage. So to start with, we have an application controller, and in this example, it has the bus power supply built in, and it connects to the DALI bus, our 2-wire bus. And this application controller might have other DALI subnets, so other DALI buses. So these are separate DALI systems, all accessible from the same application controller. And we'll just look at one of these DALI systems here, one subnet. So in this example, we've got a gateway, a router, a hub, or interface, which could connect other systems, such as building management systems, BACnet, KNX, or any other protocol. And then we have the control gear. So we've got the most common type are the LED drivers. So inside the luminaire, you've got the driver and the lamp together. You can also have emergency lighting, and that takes several different forms. You can have emergency lighting built into ceiling mounted luminaires, but even emergency exit signs. These are often DALI, and there's a huge advantage to the exit because they're testable with automatic and reporting. You have the input devices. These are providing information system. So occupancy and light sensors and push devices are some examples, but you can also get other analog and digital input devices. Each DALI subnet can have pieces of control gear and 64 control on the same bus. So that's the limitation for one bus, but of course you can have multiple buses on even one controller and then multiple controllers in a system. So that's how you would build a DALI system to be building wide or multi-building wide. Benefit lighting. So DALI for dimming, it provides repeatable, standardized light output control. This is a benefit of DALI. Our certification of DALI here follows this standardized. So all of the cert here must follow this, and this is tested. So the curve is designed to match the human eye sensitivity and brightness perception. And our tests require measurement of light. It's not just current or voltage or even digital checks over the bus, but we actually require light measurements. So light are used, automated light meters are used during the testing. Now this results in this statement that we can make. Ask for 50% light output, you get 50%. Because of the testing to ensure the control gear with a suitable connected lamp follows this dimming curve, follows the standardized dimming curve. It's consistency. And this is consistent from fixture to fixture. So that's within the same manufacturer, but also between manufacturers. So everyone follows the same dimming curve, which is tested. So you've got that consistency. DALI for color control, and this enables, so DALI enables control of the color output of 2 or more lamps from the DALI control gear. So one piece of control gear is able to control multiple lamps and control the resulting color that's produced. And there's different methods to do this allowed in DALI. So simple color control, there's 2 ways to do it. So with RGB WAF, and I'm sure you know what RGB means, but this whole acronym means red, green, blue, white, amber, free color. So you've got various colors of lamps that are available to individually be controlled and mixed to give you your resulting color. So that's just basic operation of each of these up to 6 channels. You don't have to have 6. You could just have 3 of the channels. That's quite common. But very simply, you set the level for each of these channels individually. The next type is tunable-white, the TC color type. And this provides color temperature control or correlated color temperature control. And this follows what's known as the black body line through the color space, which is a variation in color from warm white through to, from warm white at that end there on the right to cool white on the left, on the bottom left. So they're fairly simple methods of controlling color, but we also allow this precise and repeatable selection using XY, which is the chromaticity diagram you can see. So by selecting the X coordinate and the Y coordinate, you can specify the precise color. And this is repeatable as well, because it's a standardized color space. It's repeatable from fixture to fixture. Now, all of these color control methods allow smooth fading between the colors. So you can change from one position on the black body line to another. So for example, cool white to warm white, you can fade very smoothly, or from some kind of green color to some kind of red color. You can smoothly fade, from one color to another. Also for accuracy, for color accuracy, X, Y, and the TC color types allow calibration. So this combination of control gear, the driver, and the lamps can be calibrated, and that allows this repeatability and color accuracy. So tunable white is already included in the DALI-2 certification program that started in January this year. And you'll see a number of DALI-2 tunable white drivers already in our product database. And this allows control of the correlated color temperature, the CCT, along the black body line from warm white to cool white. And these drivers implement this part of the standard. It's called part 209. And it's also known as DT8. So you'll sometimes hear this on the market, device type 8 or DT8. But for tunable white, it's the TC color type. So tunable white is a good way to explain what you're getting here. And scenes allow recall and smooth fading of color as well as brightness. So you can do color and brightness together or individually. This is just one example application with over 1,000 tunable white luminaires with a very wide range of dimming, actually down to 0.1%, and color temperature from 2,500 Kelvin, so quite a warm color, to 4,000 Kelvin, a cool color. And lastly, before we hand over to Paul, let's have a quick look at emergency lighting. This is another key driver for using DALI for lighting control. And DALI provides self-contained emergency control gear, which have one main to provide light when the main supply fails. And the light output, the driver, is then powered by a battery. And self-contained means the driver battery arrangement is in the control gear or right next to it, attached right next to it. Central battery is the other type of emergency. We do have a standard for that as well. Now, this allows automated self-testing, and in many countries there is a legal requirement for periodic testing. And DALI allows both, or the two types of tests to be automated: the function test, which is a quick test of the battery, charging circuit, the driver / relay, and the lamp, and the much longer, the duration test, which checks for operation of the lamp from the battery for the rated duration. And of course, you get the feedback of all the test results and information on failures. So other information you can get, the battery charge level, the lamp operating hours, and more is available. And DALI enables illumination and emergency lighting on the same network. So you don't need separate buses, separate networks. It's just one lighting network with all of the DALI devices for the general lighting and emergency. Okay, so I'm going to hand over to Paul now for part 2.
Thanks very much, Scott. Excellent introduction. If someone can give me control. Okay, fabulous. Hopefully you all see my screen now. If not, then please stop me. So now we're going to talk about DALI in smart buildings, connectivity, introduction to the DALI Lighting Awards, and then we'll hand back to Matt for the Q&A session. So, why is it not moving? Here we go. So first up, DALI in smart buildings. So as Scott introduced, DALI is built to enable smart data-rich networks. And the start of any intelligence starts with the data, from my point of view at least. And as we already saw, DALI is a bidirectional digital communication protocol. So feedback and exchange of data is enabled by that two-way communication. Control gear can provide data on output level, lamp failure, emergency test data, and all the other good things that we've seen before. And then DALI-2 sensors and other input devices provide information and user inputs to the system to enable it to change its behavior. And as already mentioned by Scott, DIA specifications for data storage and reporting are standardized. So this means that we have data for enhanced asset management, performance monitoring, and diagnostics, as well as the luminaire control gear and light source information. So just thinking about the elements of lighting intelligence, what does that mean? As I said, I think it starts with the data, collecting the data to understand what is happening in a space. From that, then the next step is then understanding. So it's all very well having a whole lot of data, but you need to refine that data. You need to understand what's really happening, what's really useful. Then you can pick out the behavioral trends, the patterns, the activities which enable the lighting to interact with the space. So improve the space conditions, collaborate with other building systems, for example, heating and ventilation, or blinds for shutters, these kind of things. And that will result in impacting the space by improving the user experience, improving the well-being, as well as, of course, energy saving, which I think goes without saying nowadays. So we already explored the sensors and input devices. They provide information, particularly for automated control. And the user inputs then allow occupants to make adjustments to that. For example, dimming, color setting, scene recall, and other user preferences. The 4 types of input devices currently included in DALI-2. Push buttons, absolute interface input devices, which switch, sliders, and rotary, occupancy sensors, which can detect movement or presence, and light sensors, which determine the illuminance level. And there's a couple of other sensors currently in development, and the operation can be driven by events, polling, or periodic transmission. So let's look at the data that's inherent in DALI. As we said before, the data enables enhanced asset management, performance monitoring, and also diagnostics. And it's standardized in those memory banks. So standardized format, standardized locations, and that's really helpful when you're looking at luminaire to luminaire, system to system, and different manufacturers of luminaires. It's always the same. So part 251 is the luminaire data. That's information about the luminaire itself. So the ID code, light output, the CCT, CRI, light distribution. All of this is pre-programmed into the LED driver during the luminaire manufacturer process, and enables remote and good asset management. Part 252 is the energy reporting. So it's real-time power, energy usage for the LED drivers, and diagnostic data, which is the operating data for the control gear and lamps, including failure conditions, runtime data, and this enables predictive maintenance. I'm going to explore that a little bit in an example on the next page. So Taking an outdoor application as an example, it doesn't have to be outdoor, of course. This scenario would apply to any indoor or outdoor luminaire, but this is just a simple graphic to explain. So as I said, in the factory, luminaire data is pre-programmed into the drivers. It tells the luminaire what it is. When that's in the field, that can then lead to automated commissioning. So when installed, the luminaire can automatically transfer data to the remote network. The remote network knows what it is, where it is, and how it's performing. And this reduces human error, saves installation time and cost, of course. And pretty much straight away, the operator has a full map of the asset information for all of those assets. During operation, performance monitoring enables energy use data can be used for billing and these kind of things. And then predictive maintenance, so diagnostic data enables the operator to anticipate the need for maintenance, plan that maintenance very carefully. The repair team or maintenance team has advanced knowledge of the location, the type of fixture, its configuration. All of that detail can be determined up front, and this can be much more efficient in the process for performing that maintenance, reducing the downtime, which is always critical in a high use area, whether that's inside a building, so it might be in an airport, for example, or a rail station, or outdoors if you have to close a highway or an area of a parking lot, then the downtime is critical. Thinking about DALI for wellbeing and comfort, so we're talking about efficient human-centric lighting now. We can use daylight harvesting to adjust the intensity according to ambient levels throughout the day. And DALI-2 light level sensors will enable this. You can match the lighting levels to the actual utilization of the spaces via occupancy sensors. You can adjust the color temperature according to the time of day, and of course, perhaps by individual preference, by using the tunable-white, for example, and then personal control of that via user interfaces where the input devices such as push buttons, rotary controls, or even touch panels can affect those. And the result is the building occupants experience improved comfort and well-being, leading to higher productivity and ideally better staff retention. So now we're going to talk about connectivity. How does DALI fit in an IoT world? We can think about a simple IoT definition. What is IoT? It's a system of devices with unique identifiers, the ability to transfer data over a network. So let's look at that in terms of DALI. DALI devices are already individually addressable. The data exchange is inherent in DALI due to its bidirectional digital communication. And connectivity, multiple current and emerging options, including wireless, and that's what we're going to look at next. So DALI is already well positioned to participate in the Internet of Things. So let's look at the capabilities of DALI in an IoT world. So current DALI capabilities, multiple DALI subnets can be networked together, enabling building-wide control. DALI subnets can connect with other networks via non-standardized gateways today. And those gateways might include, for example, building management systems. And D4I facilitates the addition of wireless nodes to luminaires, enabling standalone luminaires that can participate in remote lighting control networks. So that's what we have today. And work in progress, which is what we're going to look at next, is DALI connectivity via wireless networks and DALI connectivity via IP-based networks. So let's explore that in a bit more detail. So combining DALI lighting control with wireless networking. we're working with several partners to standardize different options, and the goals are to create or adapt the specifications and develop test procedures and enable certification. Again, guaranteeing that interoperability that that DALI-2 promises. So the first of those that I'm going to talk to you about is DALI over wireless. And DALI over wireless, here the native commands of DALI are transported using a wireless carrier. So here there's no translation, there's no mapping of DALI to another system. It's simply DALI using another ecosystem, and in this case we're working with Bluetooth and with Thread to enable the carrying of those commands wirelessly or using IP from point to point. The other flavor that we're working on is wireless gateways. I've already talked about gateways enabling the communication to another network. So DALI to wireless gateway would translate between DALI and another wireless protocol. And here we have ecosystem partnerships where we're working with Bluetooth and the Zigbee Alliance. So let's look at that in a bit more detail. What's a wireless gateway? And how does it differ from DALI over wireless? So we'll look at wireless gateways first. So here you have a network. The purple dots are wireless devices that are connected via a non-DALI protocol. So they're not DALI devices, they're just wireless devices. The green dots are gateways to lighting, to DALI. And this might be, for example, a gateway to a D4i luminaire, which has a gateway mounted on that luminaire or integrated into the luminaire. And there you have an intraluminaire DALI bus, so DALI inside, a D4i certified LED driver, and the sensor, which is then on the DALI bus. And the gateway then, as we said, translates between DALI and the other network. And you can do the same thing for an existing wired DALI bus, so DALI-2 subnet wired with gateway, as it says here, where you might have a sensor, you might have some luminaires in a room, for example. And the gateway does the translation between DALI and Zigbee, or DALI and Bluetooth mesh lighting. And I would highlight here that there is a potential limitation, but the limitation would be on the network side. So it's down to the reason we're standardizing these things is to ensure that the mapping is consistent between and the behavior is always the same on the DALI side. And then we look at the other way of doing it, which is DALI over wireless. And here the DALI devices, so all of the wireless devices that you see here are DALI. So this could be a bunch of luminaires in a room or in a system, and they're connected wirelessly, as we put here. And here they are talking DALI to DALI. So there's no translation, there's no mapping of the behavior. The inherent behavior is DALI, and what we're doing is we're using the ecosystem partner to affect the communication, much like your mobile phone carries either your voice or your email or whatever data via another network. It's the same process here. We're using the other network to carry the native DALI commands from place to place. And to connect to an existing wired DALI network, for example, a D4i luminaire or a Zaga D4i luminaire, or an existing DALI-2 subnet, you would need a bridge that would create the physical contact between the wireless and the wired. But it's still DALI. Everywhere it's DALI. And currently in development, as I mentioned, we have DALI over Bluetooth mesh, and we also have DALI over thread, which is IP based. So the IP based is very interesting because, of course, it could enable Ethernet, and this is why, although we're talking about wired, of course, IP can also enable. Sorry, we're talking about wireless, but IP based could also enable wired Ethernet, for example, power over Ethernet. These are the things that could happen in the future. Here's a good example of what a DALI over wireless system might look like. So on the left-hand side, you have all of the wireless devices. On the right-hand side, you see there also a bridge and then connected to a typical wired DALI network. So conclusions then, DALI-2 makes a significant contribution to intelligent buildings by energy efficiency, future-proofing, well-being and comfort of occupants, and of course the predictive maintenance. DALI-2 and D4I certification increase the confidence in cross-vendor interoperability, and the specifications that we have in development will enable DALI over wireless and IP-based connectivity options, as well as the gateways to other wireless ecosystems. So final two slides before I hand back to Matt. I'll introduce you to the DALI Awards. So DALI Awards is a showcase for DALI related projects and installations around the globe. We're working in association with ARC Magazine and IALD. And there are 5 categories. As it's the first of these, we kept it nice and simple. There's a different indoor options, and then outdoor, and also Zaga D4I, which Scott mentioned earlier in the presentation. So highlights. There's no cost to enter. I'm sure that's important. We welcome projects in all geographical regions. There's no requirement for DALI Alliance membership, so the submitting organization doesn't need to be a member of DALI Alliance. And it doesn't have to be exclusively DALI. Of course, we understand that, that the best systems are those that interact. Materials should explain, so submission materials should explain why DALI was chosen and what benefits were attained by DALI. And submit your entry now via our website. There's the link, and the deadline's the end of the month. So you've got plenty of time to get those entries in. So that's all from me. I thank you very much for listening to myself and Scott, and I'm going to hand back to Matt now, and we'll take some questions. Thanks very much.
Okay, thank you very much, Paul and Scott, for those very interesting presentations. We've had plenty of questions come through already, so please keep sending those in and we'll try and get through as many as we can. The first one we've had comes from Rainier Lopez, so thank you very much for your question, who asks, with part 252 and 253, which I believe you mentioned, Paul, what are the memory size limits for data storage? So how many KB of data storage is stipulated for each DALI-2 device?
Yeah, that's one for Scott.
Yeah, so parts 252 and 253 they're not the right parts for storing data. Luminaire data is part 251, and that's one memory bank. If you need additional data storage, you can use the manufacturer-specific memory banks. Each bank is giving you 254 bytes. So, and it's your choice how many banks you use. There are quite a lot of banks there. So I'm not quite sure why the question is 252 and 253. Maybe that's just a mistake. But for the standardized Luminaire data, look in part 251.
Okay, and we've got another question here from Chuan Lim, who asks, how far away before we'll see DALI over wireless certifications or standard?
I don't want to commit any timescale on that, but we are working very hard to have specifications ready in the next few months. So I won't say when we will have certification ready, but the specifications for both the gateway solutions and the DALI over wireless, I expect to be just a few months away.
Yeah, I would complement that simply by saying that 2021 is going to be a very exciting year for DALI and wireless.
Okay, and I've got who says one of the advantages of DMX is the first communication with the drivers. In the future, will DALI be as fast as DMX?
Yeah, so a speed comparison between DMX and DALI isn't actually that useful. DMX is a long list of numbers, which typically mean the light level. And to send the level to your last driver on the DMX bus, you have to send the level to all the drivers before. So you've got to go through the full list of numbers just to change one. But DMX is very good at what it's intended to be. It's for entertainment, fast flashing lights and that kind of thing. So it doesn't have any standardized commands. There's no scene command, for example. With DALI, you've got a scene command, which within about 15 milliseconds can change the light levels for all of the lights in your system simultaneously. So no delay, no popcorn effect. It's just instant. That one command affects all control gear, all luminaires together. Whereas with DMX, you'd have to go through a complete cycle, which is about 40 milliseconds. So in that comparison, yeah, you could say DALI is faster, but of course, in DMX, you don't have scenes. You've got the flexibility of changing every level individually, but as well as flexibility, it's kind of a burden because you've got to go through all of those devices.
Yeah, the comparison's really not apples for apples, is it? It's
no,
the application for DALI is general lighting, and it does that very, very well. And the introduction of color or the flexibility of color is it's a feature of that, but it's not intended to replace DMX. I mean, DMX works very well where in a theater or an entertainment environment. So it's not really the same thing.
And the other area that we're working on, the DALI over wireless, that will be giving a speed increase, but of course it's a different carrier. It's not the 2-wire DALI bus, and the speed will depend on the underlying protocol. And more about that once we've released the specifications.
Okay, and we've had another question come through asking if you have any specific examples of how DALI weaves into indoor tunable white lighting installations, say in hotels, spas, restaurants, etc.
It's probably best to contact Tim, our marketing manager, afterwards if you want some reference applications. There was one picture on the slide I showed. It was in the Netherlands, which was a tunable white. I'm not sure what kind of building it is. But yeah, please contact us afterwards for any application examples.
Yeah, check our website first. There's a few application examples on there. And of course, after the DALI Awards, then we expect quite a few more.
Sure. And another question from Randy, who is the main factor that affects the scrambling of addresses during electrical fluctuations or brownouts?
I'm not sure what's meant there by scrambling. I'm not sure if you're describing a fault situation or not. When you have a new DALI installation, then you go through an addressing process, and the tools that are used could just randomly assign the short addresses, which is perfectly normal, and that can be done automatically, and then they can be reassigned by the installer to the required addresses if that's useful. But scrambling during fluctuations or brownouts, that doesn't happen. So for products that are operating correctly, if there's a brownout or fluctuation, the address doesn't change.
Okay, and we've had a follow-on from Rainier regarding the 252 and 25 3, sorry, just bear with me a second, says, so 252 for energy monitoring and 253 for diagnostic. What is the data storage size and how many days of data storage could be stored before old data gets overwritten?
Right, okay, so these parts are not logging a long history of operation. They have, for example, energy counters or accumulators and fault conditions. So it's not as if you get a list of what happened on Monday and Tuesday and Wednesday and Thursday. It's not like that. It's not giving that history. So the actual data that is stored is non-volatile memory, so it's not lost. It doesn't have a limited data storage time, so it will be the lifetime of the product, and it's stored through power failures as well. So the energy data that accumulates is remembered after a power cycle. So there's no limitation on that time.
Okay,
I do see a question as well, sorry to butt in, Matt. I see a question from Alan Jackson, which maybe came in privately. Right at the beginning. It was about addresses used by the application controller, where you have multiple buses, multiple subnets that the application controller is driving or connected to. So application controllers don't need to use any addresses, actually. It's their choice. There could be something else in the system that assigns them an address. But if they do, then it's just one address from that subnet that they're connected to. Even if an application controller drives 4 different DALI buses, it's not using 4 addresses from one DALI bus. Usually at most it's one address, if any, from each bus. And each additional bus it has an additional 64 control gear addresses plus 64 control device addresses. So the address space just multiplies up as you have more subnets.
Okay, we've got a few more questions come through. Thanks everyone for sending your questions through. Had one that's come through. Will DALI publish specific standards for IoT outdoor devices for Zaga D4I certification? Mean certain sensors, pole inclination, move detectors, temperature, etc.
So these devices are already part of DALI-2 and now part of D4I as well. So devices for occupancy and light level, we call these input devices, and they're part of the standard. So have a look. You can even search for those that are already certified. And it's down to manufacturers to apply for certification for those that are suitable for street lights. And I expect we will see those very soon. It's actually only about a week ago, maybe a week and a half, that we released the certification of our new part 351, which is for luminaire mounted control devices such as sensors. And that will be used by the street light detectors, which typically have a Zaga or a NEMA connector, and they will be able to get D4I certification. And with the Zaga connector, they'll be able to get Zaga D4I.
Okay, great. And we've had another question from Randy, who asks, what would be the limitations of wireless DALI in terms of area?
Just like wired DALI, there's not really a limit to that, because you can connect multiple systems or DALI subnets to make larger. But of course, the underlying protocol that's used determines how many devices are in one wireless network. And it's the usual limitations of whether it's thread or Bluetooth mesh or Zigbee that you use. So those are the limitations. But as I say, you can build the larger networks just using multiple bridges or gateways.
Yeah, I'm just sorry to butt in, but if the question is about maybe distance for the wireless connectivity, then I would say that's obviously down to the partner network. We don't control that. That would be a feature of whichever network is chosen.
Okay, and we've got another question which has come from Gabrielle, who asks, when do you think part 2 of 205 will be available?
DALI-2 for part 205. So 205 is the dimming part, the phase cut dimmer or incandescent dimmer, which nowadays is not just used for incandescent lamps, but also for the mains dimmable LED lamps. This is just starting conversion to DALI-2 now, so it will be in the next release, which we expect to be early next year. So actually 205 for the dimmer and 206, which is the 1 to 10 converter, we've just started converting the test sequences for those for DALI-2.
Okay, great. And we had another question that actually came through during the registration period that has said, are there any software tools for simulating the operation of the DALI system from simple to complex to demonstrate capabilities to customers?
So there are, I'm not sure for customers, but there are tools certainly for developers, and the company that supplies the test hardware, Lichtvision supply, they also make a simulator, so that's one place to check. But I would also check with our members. If it's specifically for customer demonstrations, then you're best to check with our members that are providing these systems. And you can find the members list on the website, and also the types of products that the members supply just through the product database. So that's probably the best way to start there.
Okay, great. We've got time for a few more questions. We've had another one come in from Robert Hudson, who says, can DALI devices already approved and installed in the field be upgraded to the latest version of the standard? Or do devices only operate on the version of the standards which they were originally approved?
Yeah, thanks for the question, Bob. Good to hear from you. So there is a part of the standard for firmware upgrade that has been published, and we are about to start on the test sequence development for that, but I don't think it'll be in the next release. I think it'll be the one after that. So it's got a little while before that will be ready. And that allows field upgrade of the firmware or even other information stored in devices. So it allows updates over the DALI bus.
Yeah, I would just complement that by saying that if anyone wants to check the current status of registration or certification of a particular product, they can check that in our database online.
Okay, great stuff. And we've got another question from Randy. Thank you for all your questions. Who says, is there complications when it comes to commissioning, since there'll be an integration of wired to a wireless system?
So you've got two ways of implementing wireless. One way is the DALI over wireless, where everything is DALI, and the other is where you're using a gateway. And the gateway method, your configuration is from what we call the ecosystem, whether it's Bluetooth mesh or Zigbee or some future ecosystem. So that's where you're configuring from. And the tools would be for that system. So probably straightforward. If they're straightforward for that system now, then I don't expect them to be any more complicated. You're just seeing more devices, the gateways. If it's purely DALI, so DALI over wireless, then you've got tools for DALI systems. So again, it's a seamless DALI system. So I don't see any great increase in complication here. But of course, it's down to the manufacturers which kind of tools they provide. So, and they vary from manufacturer to manufacturer depending on their products and the product capabilities.
Sure. Okay, so we've probably got time for one more question now. So you showed an example during the presentation of Zaga D4i for streetlight. Can this also be used for indoor applications as well?
So if you look at the Zaga books, book 18 is for outdoor. So that's the connector for outdoor, typically streetlights. They have another book for indoor streetlights. I'm not sure if it's public yet, but book 20 is for indoor luminaires. So outdoor, such as streetlights, book 18. Indoor is book 20. And once certification starts, then the luminaires and the other devices will get Zaga D4I certification, or that will be possible for those.
Okay, great. Well, I think that about is all the time that we've got for this. It's a shame. This has been a really interesting discussion. I'm sure it would have been great to carry on further. But I just want to say thank you to the DALI Alliance and also to Scott and Paul for your time and for your presentations today. And thank you to everyone that's tuned in and asked your questions as well. Just a reminder that the presentation materials and a recording of this session will be available at the date. If you did miss the start, or if you'd like to recap on anything that's been discussed, this will all be available to catch up shortly. But yes, thank you very much, everyone, for your time and for joining us today.
Thanks, Matt.